Acid can do wonders. Acid can be used for solubility test. Acid can be used for precipitating agent. So immediately you add a dilute acid. In this particular one, initially, when you add the dilute acid, my dear, you'll be seeing effervescence showing a positive change. You see effervescence occurring because acids are known to produce gases in many salts. In some of our chemical salts, acid can do what? Bring out or give out what? Gases from salt. So when you add it, dilute acid, specifically trioxonitrate 5 acid. When you add it, you will see the effervescence giving out a colorless, odorless gas, then making the salt solution to be partially dissolved. You will see the salt sample partially dissolved. Then you filter. When you filter, you now separate the soluble one and the soluble one. And mind you, in this case, when a dilute triazonitrate 5 acid is added, lead 2 nitrate is formed. The starch will be there as the colloidal solution. Looking at you there, it cannot dissolve in acid. So in this situation now, whereby the lead 2 carbonate has dissolved in that acid, giving us lead 2 nitrate, we cannot get our filtration apparatus to separate the starch and the lead 2 nitrate formed. That is, the starch will be the residue on the filter paper, while the lead 2 nitrate will move through the filter paper and be collected as a filtrate, a clear and colorless solution. We have separated. Then the examiner asks you, divide the filtrate into 3 portions for a subsequent analysis. When you dissolve the filtrate into 3 portions, so the first portion, the examiner will ask you, add dilute sodium hydroxide. Add dilute sodium hydroxide, not adenosine or the normal way of doing it, in drops and in excess. So if you add dilute sodium hydroxide in excess in drops, you will observe a white chalky precipitate. A white chalky precipitate. What are the suspected ions that can form a white chalky precipitate, not gelatinous white? Not gelatinous white, rather chalky white. What are the ions that can form this chalky white precipitate when sodium hydroxide is added? My dear, these ions we're suspecting are calcium 2 ion or lead 2 ion. That would be your conclusion or your inference, what you're suspecting. Write it. Then in excess, when the dilute sodium hydroxide is added in excess, you will observe that the white chalky precipitate dissolves, disappears. If it is student, they will say it disappears instead of using the term dissolve. When it dissolves, there is no other person, there is no other ion. Let me use ion, let me not personify. There is no other ion than what? Lead 2 ion. Calcium do not dissolve or does not dissolve in excess sodium hydroxide. Then we have seen that between the two, we have extracted ion. It is ion that must be present in this solution. It is the ion, lead 2 ion, that must be present in this filtrate. Then, in confirming it, let's go for confirmation. The examiner will ask you again, add aqueous ammonia, dilute aqueous ammonia in the second portion. You bring out the second portion, not the previous one. You added what? Sodium hydroxide. In the second portion, because you divided the filtrate into 3 portions. So in the second portion, in the separate test tube, you will add dilute aqueous ammonia, NH3 aqueous, in drops, then next. Immediately you add it in drop, you will still observe again a white chalky precipitate. When you observe the white chalky precipitate, my dear, between lead and calcium 2 ion, please. Lead 2 ion is the only ion that can have positive effect in aqueous ammonia. In aqueous ammonia, calcium 2 ion does not have any effect with dilute aqueous ammonia. Then we now confirm, even if you add it in excess again, the white chalky precipitate still remains. So we normally use this dilute aqueous solution to do what? To confirm lead 2 ion when we have a white chalk initially. Then, or the white examiner will also ask you. So the third portion, anyway, is only one or two portions you will have. Either this conformation, they use this conformation, or the one I'm going to do now, they will use the conformation using aqueous ammonia, or in second portion, they use another way of confirming after you have done with your dilute sodium hydroxide. Okay, another way of confirming this lead 2 ion, that it must be an ion present in this solution in your filtrate. The examiner may ask you to the second portion, add dilute hydrochloric acid. Immediately you add dilute hydrochloric acid in this filtrate. Remember what is a filtrate? Lead 2 nitrate, because we have converted the lead 2 carbonate to become lead 2 nitrate, which is the soluble one, the filtrate. So immediately you add dilute hydrochloric acid, the lead 2 nitrate in that filtrate. A white precipitate will form. I will still tell you who is this man, the white precipitate that's formed. Then they may ask you to heat. When you heat the mixture containing the white precipitate, you observe that the white precipitate disappear in the students. But I don't mind tell them to use dissolve. White precipitate do what? Dissolve. So when the precipitate dissolves, the examiner also asks them, allow me to cool. When you allow it to cool, you will observe that the test tube, the same cool test tube, you will still see the white precipitate reappearing. You're surprised that the white precipitate, which has been dissolved during heating, reappears on cooling. And you can confirm that the white precipitate that formed is lead 2 chloride. Because when you add dilute acid, hydrochloric acid, to a lead 2 salt, a lead 2 soluble salt, that hydrochloric acid will react with the salt to produce lead 2 chloride. And when you heat this particular PBT, lead 2 chloride solid, when you heat this lead 2 chloride solid, it dissolves during heat, but when you keep it to cool, it reappears on cooling. It is the only solid that has this behavior, that performs this behavior. If you look at my previous question in my page, you will see where I made a play of these experiments without knowing that it is coming out. It may be expected in our 2026 chemistry weighing practicals. It is expected. I'm not saying it is there. Come out. Thank you.